Hello everybody, hola a todos, cześć wszystkim. In this video, I'm going to show you how you can extend Keycloak using its rich Authenticator SPI. The example I'm going to show you is simple, but together with the source code, it's a great starting point to build more complex setup. And if you want to do super complex stuff, super complex custom authentication logic, you can do it all in Keycloak. SPIs for Java and JavaScript are very well covered in the documentation. It is also a pretty big topic which I won't be able to cover in a single video, and I really recommend you check out the documentation. Okay, so what I'm going to show you is IP-based authenticator. I'm going to walk you through it and will show you how to use it to add a custom Java authenticator and use provided out-of-the-box conditional OTP form component to build a new custom authentication flow. And my idea is simple. I want to force MFA OTP check if the user is trying to sign in from a non-trusted network. If the user uses corporate network, corporate VPN, then it is a trusted network, and I will skip OTP step. So let's do this. I will use a simple project which I wrote and I made available on GitHub. You can find a link to this project in the description of this video. You can clone it to your machine. It's a Java Maven project and you can import it into your favorite IDE. Okay, so we need a Java project with two components: factory, authenticator factory, and authenticator. The factory will create authenticator instances. It looks like this. It has to implement the authenticator factory. It has its own ID, which is identified inside the Keycloak. It has get display type, which is a more user-friendly name, which we will see in the UI. The most important method is, of course, the create method, which creates a new authenticator instance. In our case, it is IP authenticator, which I will show you in a second. Actually, this interface defines an other method that we will need, which is get config properties. We want to define allowed IP address for our authenticator. So you can define it in config properties. So I defined such config property of type string. It has its name, which I have in this static variable, and I set a label and help text which are actually shown in the UI. So I will be able to configure my IP authenticator and I will be able to set allowed IP address for every instance of the IP authenticator that I will be using. So let's take a look at how the IP authenticator implementation looks like. Okay, it has to implement the authenticator interface, and the most important method in this interface is the authenticate. It takes one object as an argument, authentication flow context. From the context I can get some interesting objects that I can use to implement my custom authentication logic. In here I'm using the Keycloak session, rel model and user model. Okay, so the logic looks like this. From the connection, I get the remote IP address. I also get the allowed IP address from where? From the config, from the authenticator config, which I defined at the IP authenticator factory level. And here is where I get the value which I will set in the UI. So now that I have these two values, I compare them. If they differ, I print any information in the log, and I also set a user attribute of this value, IP underscore based underscore OTP underscore conditional, to either force or skip. I will set it to force if the IP addresses will differ. I will set it to skip if the addresses match, and in this case I assume that the user is coming from a trusted network and I don't have to do additional MFA OTP verification. In this method I'm always calling context success. If I would like to be more rigorous and, for example, always fail the authentication when the IP addresses differ, I could remove just this body in here and write context.failure, provide error code in this method, and then return it. This way Keycloak would always stop here and will present an error to the end user. But for me, for this example, I will only force MFA or skip it. That is why I always call context.success. Okay, last final note. I have to provide the authenticator factory implementation name inside this file. That's the name of the interface, and in here I provide the implementation of this interface. When we will build the jar file and deploy it to Keycloak, Keycloak will read this file, will read the name of the authenticator factory, and will use this factory to create instances of our IP authenticator. Okay, so let's build it now. Maven package, and then I will copy the jar file to Keycloak home slash standalone slash deployments. Okay, and I see that there was a redeployment because I actually already deployed this authenticator to my Keycloak, but we can see that Keycloak detected it and redeployed it. Okay, so let's see how we can configure a new authentication flow. Okay, so this is the default browser authentication flow. As you can see, I cannot really change it, so I have to make a copy of it. I will call it MFA skip for trusted networks, and you can see that I can now actually change the order, and I have some additional actions that I can perform on these items. So Kerberos is disabled, so I'm going to actually delete it, and we can actually see that at the top level there are three alternative um, auth steps. The first one is cookie. It means that if I already authenticated in Keycloak and I will be redirected to Keycloak, Keycloak will actually check the cookie, and if the cookie is still valid, it will not ask you for your username and password or MFA. It will simply redirect you back to the application with an information that you are successfully authenticated already. The second option, identity provider redirector, if we set up this step, it will redirect you to the identity provider website. The identity provider will actually, similar to Keycloak cookie, will detect its own cookie, will verify if you are already signed in into identity provider, and if so, it will return to Keycloak, and the Keycloak in turn will return to you or to the end user. And the third alternative step is the forms step. So if this will fail, forms step will kick in, and the form steps contains the username password form and an conditional MFA step. If you actually at the realm level require MFA setup, then it will actually be required for all the users. All the users will have to, as a part of their sign in journey, will have to provide the MFA OTP token. So I'm going to actually remove this part and replace it with our own authentication flow. So I'm actually going to delete this part. Okay, so I will add the first component, and it will be our IP authenticator, right? That's the display name which we saw earlier in the Java code, and hit save. I showed you in the code that there's a config available for this authenticator, and if you click actions, you can actually see it. Okay, so that's the label which we configured in the Java code, and if we hover over the question mark, there is the help text that we also saw in the Java code. So as you can see from this help text and also by looking at the source code, you know that I'm doing a simple Java string equals method, so I only accept IP addresses. I don't support masks or ranges or anything complex, just IP addresses, and they have to equal. I have to provide an alias, so I will call it IP authenticator, and for the purpose of the demo, let's assume that my trusted network is 10.0.0.1. Okay, and now let's add another execution, and this time I will add conditional OTP form. This conditional OTP form, I'll mark it as required, differs from the standard OTP form in a way that you can configure it. And if you click actions, you can see that yes, there's config. In here, you can see that you can actually either skip or force OTP based on roles or headers. And in my example, I actually used OTP control using the user attribute. And if you hover over the question marks, it will actually tell you that if you want to force the OTP, it has to have a value of force, and if you want to skip it, it has to have a value of skip. So the user attribute, I will copy it from our source code. That's this attribute that we will be setting to either force or skip. And then in the Keycloak conditional OTP form, we will check this attribute fully automatically. So it will be IP Authenticator. Okay, and important thing to remember, set the fallback OTP handling, play it safe, and set it to force. Whenever there is an error or a problem with any of these, it's actually the best way to actually force OTP just in case. Okay, and the authentication flow looks like this. Okay, if you want to use it, we have to change the bindings. The default browser flow is still browser, so we are going to change it to MFA skip for trusted networks, and I'm going to click save. Okay, I'm in customer 2, so I will change and log in with my test user. Okay, so it expired, so one more attempt. Okay, and I presented with one-time code. So that's actually the conditional OTP form that we see in here. And let's quickly take a look at the Keycloak console, and you can actually see that we see the message that we generate when IP do not match, and you can see that the realm customer 99 expected 10.0.0.1 IP address, but user L2 logged from the localhost. And yes, I'm actually using localhost for the purpose of this demo, and yes, we can see that I was forced to conditional OTP form step. So to make IP address match, I'm actually going to change the allowed IP address. I'm going to config, and I will change it to loopback. Okay, and I'm going to save it. I'm going to restart login, and this time I'm logged in into Keycloak, and I go straight to my account page. So the OTP step didn't show up because I came from a trusted network. So guys, with the Keycloak's SPI, you can build any complex authentication flows that you want. For example, if you have a separate Keycloak client that you use to, for example, authenticate users to your critical production system, you can you can make a call to Jira. If you have some sort of ticketing system that, for example, contain approvals for the users, you can check if the user that is signing in has a ticket created in this system and the ticket was approved by a manager or by another peer, and only then, for example, allow the user to sign in into your application. So basically, sky is the limit. You can do really complex things with the Authenticator SPI in Keycloak. So guys, that's all for this video. If you liked the video, hit the like button and subscribe to my channel. Thanks.